How you doing, Sioux High Earth Science students? Yeah, that's right. This is Mr. McLeod again. Welcome to the Part 2 podcast in our continuing discussion of the Earth, Sun, and Moon system. In this podcast, we will briefly review the tides and get into moon phases and the seasons. So get your notes out, something to write with, and let's ride. First, let's quickly review the tides and the positions of the Earth, Sun, and Moon during the different tides. This slide shows the position of the Sun, Moon, and Earth during spring tides. So we're talking about spring tides now. So spring tides. If you don't have this diagram in your notes, you should get it there now to remind yourself. Now what I want you to write is that during the time of new and full moons, the sun and moon are in a straight line like is shown here. So write that down in your notes. Now we're going to talk in more detail about moon phases in a bit. But in this picture, the moon is on the opposite side of the Earth than the sun. So you have the moon here, and then in between the sun and the moon you have the Earth. Most often this is when a full moon occurs, because one side of the moon is lit up by the sun and visible from the Earth. That is, unless there's an eclipse, but more about that later. So what this means now is that the sun in this position is able to light up this face of the moon if the moon is above the Earth, which it normally is. It moves up and down, and we'll talk about that here in a second. But when it's above the Earth, that face can get lit up, so we see a full moon. So we'll talk about that here in a bit. Now, I also want you to write that during the time of a new and full moon, the sun, moon, and Earth are in a straight line. And that causes the spring tides. Now, the spring tides are what brings the very highest and very lowest tides. So if you want to remind yourself of that, write that in your notes as well. Now, I would also like you to write that it's the combined gravitational pull from both the sun and the moon that produces spring tides. And also make sure that you have that this is when the high tides are very high and the low tides are very low. Again, I want to remind you to ask you to tell my main story about the tides if I haven't done it already in class. Now in this slide we see the position of the sun, earth, and moon during neap tides. Again, if you don't have this in your diagram in your notes yet, get it there now. Now write that during neap tides, the sun and moon are at right angles from the Earth. And you see that here in this drawing. You see that they're at right angles to each other. The moon, Earth, and the sun are at right angles. They're not lined up like they were in spring tides. Again, we're about to talk about moon phases. But when the moon is in this position, these would be called the quarter phases of the moon. But more about that soon. Now what I want you to know and write about is that the gravitational pull on the oceans is at its least when the sun, earth, and moon are in these positions, and that therefore there's a smaller difference in the tides. Smaller difference. Greatest difference during the spring tides, least difference in the tides during neap tides. So make sure you have that in your notes. Now here's an example of the huge difference a neap tide can make in a specific location. This is in Nova Scotia's Hull Harbor at high and low tide. There's 48 feet of difference between high and low tide during neap tides. That's a lot. Okay, now let's talk about the action of the Earth revolving around the sun. In your notes, write that it takes 365.25 days for the Earth to orbit the sun. 365.25 days for the Earth to orbit the sun. Just a little longer than 365 days. Now, I would also like you to write in your notes that if we didn't add a day on February 29th nearly every 4 years, we would lose almost 6 hours off our calendar every year. So if we didn't add a day nearly every 4 years, February 29th, we would lose almost 6 hours off our calendar every year. Now, just for your information, after only 100 years, we'd be off about 24 days. Now, in your notes, add that we call that day every 4 years a leap day. February 29th is a leap day, and the year it's added is called a leap year. Make sure you understand why. Now, man, imagine if you were born on February 29th. That means you could only have a birthday every 4 years. Wow, would that ever suck? Now, also recall that the Earth's orbit is called an ellipse. And you see this elliptical orbit pictured in the diagram above as the Earth rotates around the sun. If you need to get this diagram in your notes, do it now. Also recall that the distance between the Earth and Sun changes during the year because the orbit's not a circle. And although the average distance is 150 million kilometers, or 93 million miles, it varies during the year from closest in the winter to furthest away in the summer. If you don't have that in your notes, it's critical that you get it in there now. Now, it's also worth mentioning that the Earth's tilt on its axis remains in the same direction. Write that in your notes. Now, it's a misconception that somehow the Earth's axis leans forward in the summer and somehow changes to lean away in the winter. That's not what happens. We'll talk more about this shortly. Okay, let's look at the revolution of the Earth around the sun in some greater detail. First, let's look at the tilt of the Earth again. Take a look at the diagram in this slide. More specifically, at the tilt of the Earth in its orbit path around the sun, and let's smash a huge misconception. What I want you to look at is the Earth's tilt, and that will be reflected in the Earth's axes. You see now that the axes are right through the center of the Earth, and I want you to look at these angles. Right up here it says 23.5 degrees. You already know that the Earth got bumped out of its normal axis. So look at where these are pointed. See that they're all pointing in the same direction no matter what season it is. So they're all pointed in the same direction no matter what season it is. Now, write in your notes that most people believe that somehow the Earth's tilt changes from season to season. Write that down. Now, what that means is people believe that it leans forward in the summer and somehow magically leans away during winter. Wrong. Just like the Earth has the moon in tidal lock, the sun has the earth in tidal lock as well. Write that in your notes. Now, because the earth is locked in its position by the sun, it simply can't change the way it leans every season. Write that down as well. Now let's look at what really happens. Again, look at the diagram here. You can see that the earth revolves around the sun and that the tilt remains constant in the entire orbit path the earth takes around the sun. So if we look at these axes, we can see that they're all pointed in the same direction as it revolves now around the sun. Because the earth is in tidal lock, that angle cannot change. Now, write in your notes that it's the tilt of the earth that causes the seasons. A good many people believe that it's the distance of the earth from the sun that causes the seasons. No. In fact, you can see by this diagram that in January, our winter, so right over here in January, our winter, the earth is at its closest distance to the sun in 147 million kilometers. It's at its closest distance to the sun. While in July, over here, which would be the middle of our summer, our sun is at its furthest away, 152 million kilometers. Write that in your notes. Okay, now let's start talking about timing benchmarks as our Earth orbits the sun. Let's start with important dates and what happens on those dates. So let's start with summer. Yes, contrary to what people think, summer is coming. Again, look at this diagram and find June 22nd. June 22nd is right here. So write that date in your notes, June 22nd. And after it, write the words summer solstice, which is right down here. Write the words summer solstice. Now, this is the day summer starts, supposedly. Now, write in your notes that this is the longest day of the year. So June 22nd is the longest day of the year. Now, here's what that means. On June 22nd, we have 16 hours of daylight and only 8 hours of darkness. Also, write that down. Now, from that day on, meaning June 22nd, from that day on, as the Earth travels now around its orbit path, the days get progressively shorter and the nights get longer. Write that down. The play just concluded. Now, also write down that our sun is as far north as it will get during the year on June 22nd. That on June 22nd, our sun is as far north as it can get. Therefore, we get the most direct sun rays on that date in the northern hemisphere. Again, get that in your notes. I know this is a lot, but it's really important. So on June 22nd, sun is as far north as it can get. we get the most direct sun rays on that date. Now let's look at the tilt of the Earth and see why it's summer in the north. So over here now we're going to look at this diagram right here, and you'll see that part of it is dark, that's this part right here, and part of it is lit up, that's this part here. And you can see that the United States is right here. In your notes, write that the northern hemisphere is tilted towards the sun in the summer. And you can see that right here. It's tilted toward the sun, it's lit up. Tilted toward the sun in the summer. Therefore, gets the most direct rays it will ever get. So make sure you get that in your notes. Now, what does that mean? More direct rays means the ground absorbs the most radiation from the sun, which then heats the atmosphere at the maximum rate. Therefore, we get summer warmth. Write that down. Okay, now on to fall, which starts on September 23rd, also called autumn, by the way. So here's September 23rd. So our sun now has cruised around in its orbit and begins to kind of get less and less direct here. So now we're all the way around here to September 23rd. So write the date, September 23rd, in your notes. Then write that this is the autumnal equinox. See up here the word autumnal equinox. Write that down in your notes. Now, equinox sounds like the word equal, and that's for good reason. On September 23rd, we have equal amounts of day and night, meaning 12 hours of each. Thus the name equinox. So get that in your notes. Now the days continue to get shorter and the nights continue to get longer, and you should understand that it starts to get cooler because the ground is no longer absorbing the same amount of direct rays. Write that down. Also write that the sun is now halfway done with its journey southward in our sky. It's halfway done with its journey southward in our sky. Remember over here on June 22nd, it was as far north as it can get. Well, now it's traveling southward. So now in our sky, it's traveling in the south. You can actually track it, and you can see that sun moving day to day southward. Now, because of this, we get less and less direct rays. So take a look at this now. If we look at this diagram here, this is as direct a rays as we're going to get right here. Now what you have is the Earth at a right angle to the sun. So the Earth's axis is at a right angle to the sun. So we're getting less and less direct rays as the Earth cruises in its orbit. Again, look at our diagram. Now the tilt of the Earth is again at a right angle to the sun, and instead of pointing directly at it. Because it's at a right angle, we get less and less direct rays. Less and less direct rays means less ground heating. So if the ground isn't heating, the atmosphere isn't heating, so the temperature is now cooling off. Write that in your notes.